All right, so I said we were going to take a look at question 20.30. You can see I have it set up here. So let's do a little bit of retrosynthesis. For the first one, we're taking an ester, and then we're converting it into an acid chloride. So again, we're starting with an ester, and then we're making an acid chloride. And we know only one way to make an acid chloride. Right? We literally know one way, and that is to have the carboxylic acid and then to use thionyl chloride, SOCl2. So really the only option we have is to hydrolyze the ester to the carboxylic acid and then make the acid chloride from the carboxylic acid. So we're going to hydrolyze this. So all you have to do for the hydrolysis is just write H3O plus, right? You add water and acid, right? It's going to be a dilute acid solution. It's going to be mostly water, and that's going to hydrolyze it down to the carboxylic acid. So here's our carboxylic acid, and then we treat that with thionyl chloride, SOCl2, and that is going to give us the acid chloride. Now, out of these two reactions, this is the only one that I ask you to know the mechanism to. That's going to be the hydrolysis of an ester in acid. It's the reverse of Fischer esterification, but that mechanism I expect you to know. The next one, and again, this is still 20.30. We're taking a carboxylic acid and we're converting it to a primary amine. And in terms of a retrosynthesis for this one, what I think the best idea would be to make the primary amine from the acid chloride, because if we have from the amide, because if we have the amide, which we can make from the acid chloride, of course, we can just reduce that with lithium aluminum hydride, and that's going to give us the primary amine after workup with water. So then the question becomes, well, how do I get from here to here? And the way that we do that is by making the acid chloride, right? That was one of the first reactions that we went over today, is first we would convert that to the acid chloride using thionyl chloride. That gives us the acid chloride, which is going to look like this. There we go. And then we're going to treat that with excess ammonia to give us our primary amide. So this gives us the primary amide. So remember, primary, secondary, tertiary amide, but this is a primary amide. And then to reduce that down to the primary amine, we're going to use lithium aluminum hydride in the first step. In the second step, we use H2O, not hydronium, because that would protonate it and give you the ammonium ion, like that. So again, a little bit of retrosynthesis for this one. The next one, we're taking acetic anhydride. So this is acetic anhydride, and we're going to convert that to acetyl or acetyl chloride, just what you would call it, or you could call it ethanoyl chloride. Either way is fine. Okay, and we talked about the hydrolysis of acetic anhydride just by treating it with H3O plus, so aqueous acid, and that's going to blow it apart to give us acetic acid. And then all we have to do is to convert that to the acid chloride using thionyl chloride. For the first step, I would even accept, instead of H3O plus, you could even put just H2O. If you put acetic anhydride in water, it's electrophilic enough that it's going to hydrolyze it down to the carboxylic acid. And the last one is taking the ethyl ester and making a primary amide. And so this is very similar to the other one of the other reactions that we looked at. Right? If we want to make the primary amide, the primary amine, we're going to make that from the primary amide. Right? And that's just going to require a lithium aluminum hydride reduction. So then the question becomes, well, how do I get from here to here? Well, we would make this from the acid chloride. And so we just have to make the acid chloride from the ester. So the first thing we have to do is hydrolyze it. So if we hydrolyze it using aqueous acid, that's going to give us the carboxylic acid. Then we can convert that into the acid chloride using thionyl chloride. Then we can convert that into the primary amide. So I'm just going to erase some of my work. I'm going to erase some of my work here. So that's going to convert, we're going to convert it into the primary amide by treating it with excess ammonia, like that. That makes the primary amide. And then the last step is going to be lithium aluminum hydride reduction, followed by treatment with H2O, not H3O plus, because that would protonate to give you the ammonium ion. All right, there we have it. So that covers 20.30. Let's take a look at a couple other ones. Okay, let's take a look at 20.32. So this is 20.32A. We're starting it with benzoic acid. So now we've got an aromatic ring, and we want to convert it into this secondary alcohol. So this is going to require the use of a few more of our reactions. Now this we could make from a cuprate, right? Because we know that if we can make the acid chloride, right? If we could make the acid chloride out of that carboxylic acid, which is relatively straightforward, we just use SOCl2. In that case, we can add the ethyl cuprate, so that would be the lithium diethyl cuprate ion, and that's going to give us the ketone, right? Because we're only going to add one ethyl group, but then we can just reduce the ketone to an alcohol using sodium borohydride or lithium aluminum hydride. If you don't follow me, let me show you what I mean. So my first step is going to be to make the acid chloride. I'm pretty sure that everybody's got that one. So if I just put this, okay, there's my acid chloride. Then in the next step, if I use the lithium diethyl cuprate, then I'm going to end up with this compound. So I end up with the ketone like that. And then in the last step, all I have to do is treat that with sodium borohydride or lithium aluminum hydride. I've used lithium aluminum hydride a lot today. So I'm just going to put sodium borohydride, and we could use any solvent, ethanol, methanol, water. So I'll just put water as the solvent here. In 20.32b, we're starting out with bromobenzene, this compound here, and we want to make an ester, and we want to make this ester, let me make sure I've got it right, like this. Now this one, you notice that this is an acetyl group, okay? And we know that we can put the acetyl group on, right? Because we talked about putting an acetyl group on, right? For that, we just need acetic anhydride, right? And that does the acetylation, just like in Tylenol synthesis or in aspirin synthesis. So now the question becomes, well, how do I get from here to here? Well, there's probably more than one way that you could do that, but the easiest way would be to make the carboxylic acid from the Grignard and then reduce it all the way down to the alcohol. So if you're not following me, what I mean is, in the first step, we're going to treat this with magnesium. That's going to make the Grignard. In step 2, we use CO2 as our electrophile. In step 3, we treat it with hydronium or aqueous acid, and that is going to give us benzoic acid. Now we can reduce the benzoic acid down to the alcohol by first using lithium aluminum hydride, followed by treatment with H3O plus. That's going to give me this compound, which is called benzyl alcohol. And then to do the acetylation, I'm just going to use acetic anhydride, or alternatively, I could use the acid chloride. That would work as well. Either one is fine. Maybe this time we'll use the acid chloride. So we'll use acetyl chloride and pyridine, and that is going to add the acetyl group. But again, acetic anhydride would work too. All right, let's try one more. This is 20.32, and this is C. So we're starting out with this compound, which is called benzonitrile. And now we're making this compound. So where we have this geminal dimethyl, oxygen, and then we have another acetyl group on here. So we know how to put on an acetyl group. So the main thing would be Once we know how to do that, all we need to do is make this compound, would be to make the alcohol, and then we can add the acetyl group. So how do we make this compound from the nitrile? Well, if I had the acid chloride, then I could use excess Grignard, methyl Grignard, and that would add the two methyl groups and give me that alcohol. If you're not following me, let me show you what I mean. So I'm going to have to go down here maybe. Let's see here if I can squeeze this on here. So this is 20.32 C. So what I mean is this. If I start with my nitrile and I hydrolyze that, okay, so if I use H3O plus and I cook that up, that's going to take me all the way to the carboxylic acid. So now I've got some benzoic acid, and I can treat that with thionyl chloride, SOCl2, and that's going to give me the acid chloride. Now, once I've got the acid chloride, it's going to react in a similar fashion to an ester with a Grignard. So if I use excess methyl magnesium bromide followed by treatment with aqueous acid, that's going to give me what? It's going to give me the alcohol that I want. So I'm going to end up with this alcohol, and that was the alcohol I was looking for all along. Now again, to add the acetyl group, I can either use acetic anhydride or I could use acetyl chloride and pyridine, and that's going to put the acetyl group on here like that. And so I'm going to end up with what compound? I'm going to have my two CHEM dimethyls, my oxygen, and my acetyl group like that. Okay.